Uh, Good morning. I hope that you can hear me. Can you also see the iPad screen?
Yes.
And what about Geogebra now? Okay, thank you. Okay, so if you remember, we started the topic of integrals, and of course, we haven't talked about integrals formally yet, but we started with a famous problem of finding the areas of different regions with the boundaries that are not necessarily straight lines, because usually if you have a region bounded by straight lines, it's easy to calculate its area, yes, because you can then partition that area into triangles essentially, and then you can calculate the area of each triangle and add them up, and that would be the area of your region, of course. But the interesting problem happens that if you have a region bounded by curves, okay? So we want to go through this problem one by one. So here we talked about the region, which is bounded again by two straight lines, but at least one of them is a curve. One of the boundary lines is a curve. And we were supposed to find the area of this, but we explained what is the meaning of a Riemann sum. If you remember, we said that, okay, we start partitioning this interval. For example, assume that we are interested in calculating the area below the function y equals to x squared, and then limited between the x-axis and this vertical line which passes through x equals to 4. Yes? And then we said that, okay, we can start partitioning this interval into finer subintervals, and then instead of calculating the real area that is my goal, I can calculate the area of each one of these rectangles and add them up. This, of course, it is clear intuitively that it's not exactly the area that I want to calculate, but it might be reasonably close to that area. But the whole important point is that this method can be improved. This is the important thing. And you can reach to the real area, but by any desired accuracy that you might need. How? By increasing the number of rectangles that we are considering. So here we consider 3 rectangles and add the areas of these 3 rectangles. We got a different number for the area, but it is intuitively clear, hopefully if you remember the previous lesson, it's intuitively clear that the area now, the sum of the areas of the rectangles now is closer to the real area that I want to find. If I make it more, still I am far from the real value, but still the value of the areas that I gets closer to the real value. And I showed you a demonstration on Geogebra that if I go up to 500 only rectangles, then probably our eyes is not able to detect the difference between the sum of the areas of rectangles and the real area. But of course, for mathematicians, they don't want to have a smallest error in their calculations, so 500 is not a very big number. We send that number to infinity, okay, and we try to convince ourselves that it's a good formula for calculating the area under the curve that I wanted. So do you remember that if I ask you what are these, I would say that each one of these is the area of one of those rectangles, and then we are adding them up by this sigma, and n is the number of rectangles, and then I am taking the limit of this sum when n goes to infinity. It means that the number of rectangles, I am considering infinitely many, essentially, rectangles. So some terminologies, if I want to remind you from the previous session, what was delta x? Do you remember? If I partition my interval to subintervals, the length of each one of these subintervals is called delta x. Of course, it is clear that when I consider more rectangles, the delta x becomes smaller and smaller. So when n goes to infinity, if I ask you what happens to delta x, can you tell me what will happen to delta x when n goes to infinity?
Becomes smaller.
Becomes smaller. So let me ask you one question. What happens to delta x in the limit when n goes to infinity? Can you write something in front of this limit?
0.
0, thank you. So it means that in the limit, the number of rectangles, when the number of rectangles increases, delta x shrinks and becomes closer and closer to 0. In limit, the limit of delta x when n goes to infinity is actually 0. And what was mk? Do you remember? Each one of these subintervals that you consider, there is a midpoint in each one of them. Of course, this is not necessary you choose the midpoint, but this is the strategy in the book, so I'm following it. Okay, so if I ask you what is M1, you would say M1 is the midpoint of the first interval. If I ask you what is M2, you would say it is the midpoint of the second interval, and continue so forth. Okay, so you calculate this sum and it becomes the area. What I wanted to convince you is that this is reasonable. That's it. I just want to convince you what I have written here in this box is reasonable. But might be it is not practical that much, because first of all, I am doing an operation infinitely many times. In reality, if I want to do something in infinitely many times, it takes infinitely many hours, and it is useless, yes? But sometimes I just wanted to show that this is not that useless. Okay, at least we can calculate some areas using this idea. Okay, and if you remember, I started giving you a simple example of finding the area between this line. Instead of considering y equals to x squared, I considered a simpler function, y equals to x, and then I confined myself between 0 and 1, and I wanted to calculate this area. Of course, you immediately realize this area is so simple that you can calculate it in 1 second actually, because this is 1, this is 1, so it means that the area of a right angled triangle is the product of these two lengths and divided by 2. But that was not my goal. My goal is to show that even though this formula that we had here seems hopeless because of infinitely many times repetition, but sometimes it works because mathematicians have already, of course these days, have already found a systematic way of calculating limits. But there is still an obstacle, so let me describe that. So what I did, this calculation, this messy calculation that you see here, is actually calculating the area of this using this formula. I want to do another one today, okay? And then after all these messy calculations, you see that you get the answer 1/2, which is exactly the answer that we knew. So this is actually confirming that what we have intuitively is working. And then I also describe you a method invented by actually, or I don't know, invented or discovered by Newton, and then this is the first time you see why we are interested in calculating primitive functions. Yes, if you remember, if you go back to the lessons, I told you that for the time being, let us consider this just as a mathematical curiosity or game. I give you a function and I ask you, can you give me a function whose derivative is this function? Well, let us play this game, and then we learned quite a lot actually in finding primitive functions of different functions at the level of matrices, of course. Newton realized, I'm telling you, this is why primitive functions became actually important, because Newton realized instead of doing this messy calculation, okay, one can do this. One can ask himself or herself that what is a primitive function of my function? And this is so simple that every one of you knows about that. It is x squared divided by 2. And then Newton said that, okay, in which area you are interested, you are limited between 0 and 1. So what you do, you find the primitive function for your function. You put the bigger number instead of x. Here is the bigger number is 1. Yes, and the lower number is 0. You calculate these two and then subtract them. What you get is your answer. Of course, Newton method, you see, it's very, very simple, but it's a little bit harder than this one, of course, because this is an extreme case. It was so simple that we already knew a formula for that. But now today, I want to do this calculation for this parabola, and I want to show you that this is also working here. So none of them will be part of Math 3C lesson. I don't know, some people might consider it university problem, but I don't think this is so hard that you don't understand that. Of course, this is not demanded in the exam or whatever. So I want to start at more or less a very tedious calculation today now for you. So I would say that if you don't like to see these kinds of calculations, you can take a nap for, I don't know, 40 minutes, and then when it is time, I will wake you up, okay? So today we want to calculate the area. By the way, this calculation Archimedes did it, I think 300 BC, or I don't know, nearly 2500 years ago, okay? But of course with a little bit more complicated method. Instead of considering rectangles and adding the areas of rectangles, Archimedes actually considered the areas of triangles in a very specific way, and then adding the areas of triangles to come up to the real answer, to the exact value of the area.
Is it possible to use any geometric figure?
Pardon?
Possible to use circles?
Possible to use? I didn't. Your voice was not clear.
Is it possible to use the circles to find the area?
I haven't seen that. Might be you can come up with an answer yourself. I don't know. Now the reason, no, let me first of all, even if the reason that we consider rectangles or triangles, because these are those geometric shapes that we already know the area. Of course, we also know the area of the circles, but calculating the areas of circles itself is a different problem itself. So you need to find a method to be able to calculate. Have you ever asked yourself how do we know that the area of a circle is pi times its radius squared? So one way to find those areas is actually using integrals, and there is another way, and that is the limit process. So I think rectangles and triangles, the shapes which are bounded by straight line segments are better candidates because we already know the areas of them. I don't know if I could answer your question or not. Yes or no?
Yeah.
Okay. Okay, so yeah, the people interested, yeah, they should be on board. Others go to bed and sleep. Come back after half an hour. Okay, I'm just kidding. Anyway, I just want to make sure that you are not worried about calculations, because if you are always thinking about the exam, you will not be able to enjoy the journey. Yes. So let us try and see what happens for this calculation. So if you see, let me repeat the problem. Let me write the formula here. So I want to calculate the area using this formula, the limit of the Riemann sum. The Riemann sum is this sigma f of m sub k delta x, and then k goes from 1 to n. N is the number of rectangles, but of course I want to send n to infinity to find this area. Okay, so this is our formula. Okay, I want you to help me to do it if you're interested, of course. So here, this number is 0. Do you remember? So this one is 0. So let me change my color here. This number was 4. This number is 0. Okay, so if you remember, the first number is called x node, and the last number is called x sub n if I want to have n partitions, n subintervals. Okay, and then because I don't want to confuse you, I just concentrate on one of these rectangles. Say that this is the kth rectangle, rectangle number k. Okay, so it means that this point, for example, the first rectangle is between x0 and x1. This is the first rectangle. The second rectangle is from x1 to x2. So when I say second, you see the right end point is 2, the other one is 1 unit less. Okay, so when I say the kth rectangle, okay, tell me if you are on board with me. So what should I write below this point? And what should I write below the right hand point?
xk and xk plus 1.
No, be careful. You are close but not 100% correct. You are actually very close. You made a mistake. Let us repeat. What is the first rectangle? The first rectangle is between x node and x1. This is the first rectangle constructed here, yes? I don't want to spend time on it. And then x1 to x2 is which rectangle? Is the second rectangle. So when you say first rectangle, the right hand side one is 1. When you say second rectangle, the right hand side one is 2. So when I say the kth rectangle, which one is x sub k? Which one? Hello, are you with me or not? What happened?
2.5.
Pardon?
2.5.
No, forget about. You didn't understand what I'm saying. I am saying that I have from x node to xn. I want to start dividing it to n pieces, n equal pieces. Okay. So let me just draw and clean it again. So I have this. Here is 0. Here is 4. I divide it to n equal pieces. I don't know what n is, so let me pretend that n is this value. I don't know, this much. I divide them into n pieces. If I ask you which interval is that, you say this is the first interval. Which interval is this? This is the second interval. Which interval is this? This is the third interval, yes? And I told you that the first number we say it is x node, the second number is x1, the next number is x2, the next number is x3. I continue, I reach to the last one is xn. And now assume that you continue, let me make it bigger, you continue and then you continue. Assume that this is the kth interval. Okay? Now I am asking, can you tell me what should I write for the left hand side question mark and the right hand side question mark if you continue this pattern?
x4, x5.
No, this is not x. This is the first, second, third, you continue. This is not the fourth one. I continue until I reach to the kth one.
No, that's 5.
Oh no, it's xk minus 1 and then xk.
Yes, I don't know, Martin, why do you say 5? So you see, this is the first one, this is the second one, this is the third one. I continue, I don't know how many times I continue, but I reach to the kth one. This is number k. Okay?
Number k.
So do you understand or not?
Yes, okay.
If not, please let me know so that I can explain.
I get it.
Okay, good. So then hopefully everyone agrees that this question mark is what? X, X. What should I put here? What should I put here? It's not hard to see. When I have the third interval, the right one is 3, the left one is 2. When I have the second one, the right one is 2, the left one is 1. When I have the first one, the right one is 1, the left one is 1 unit less. So when I am working on the kth one, so what is this one? This is k, this is 1 unit less. Agree with me or not? Yes? Okay. So I clean this because we don't need that. So what I do here, I would write x sub k minus 1, x sub k. So if you ask me what I am doing, I have a lot of these rectangles, I have a lot of these rectangles. I don't want to disturb ourselves by drawing those rectangles. I am just concentrating on one of them, the kth one, okay? Now, let us go back here. If I want to, do you remember, if I want to find, in this case, if I want to find x1, x1 is delta x more than x0. So x1 is 0 plus 1 delta x. Delta x is this length, yes? If I ask you what is x2, x2 is x0 plus 2 delta x. Is that understandable for everyone? Let me show you in this picture. Make it bigger. Here is 0. If I ask you what is x1, of course you can see the number, but don't forget about the number. It is clear that I need to add this delta x to 0, then I will be here. If I want to find x2, I start from x0, but I add 2 delta x's, 1 and 2. If I want to calculate x3, I start from 0, but I add 1, 2, and 3 delta x's. Is that understandable for everyone or not? Yeah? Okay. So now, if I ask you what is this, what is xk, now can you tell me what is xk? If you understand exactly what's going on, you should be able to answer that. Can you tell me what is x sub k?
x0 plus k delta x.
Yes, x0. But what is x0? x0 is the origin. It is 0 plus k delta x. So xk is k delta x. Okay, this is something very simple. If you don't understand, please let me know. Okay. Now can you tell me what would be x sub k minus 1? To test your understanding. Of course, we also need it. What is x sub k minus 1? Waiting.
K minus 1 multiplied by delta x.
Yes, why you are hesitating? So x sub any number is that number multiplied by delta x. Now I have x sub k minus 1. It means that this becomes k minus 1 delta x. Yeah, I thought that it shouldn't be hard. If you find it hard, please let me know so that I can repeat and discuss, because these things are important. This is not something I shouldn't mention that this is probably university problem. Yeah, forget about this. This is exactly what the Archimedes realized that 400 BC without probably going to university like us. So it is probably manageable for you as well. So everyone happy with these two boxes, gray boxes?
Yes.
Okay, now another question. What can I write for delta x in terms of n, the number of rectangles? Delta x is where is delta x? Let me show it for you. The delta x is the width of every one of these rectangles. Can you tell me what is delta x in this setup in terms of n? Okay, let me go back here. If I ask you what is delta x in this case, you can read it from the picture. What is delta x here? How much is delta x? Is 2. How did you get it? The number was 4. I wanted to have 2 rectangles, so I divided 4 by 2. Now let us go here to this one. I have 0 to 4, but I want to divide it to 4 rectangles. So what is the width of each one of them? It is 4 divided by 4, because the total length is 4. I want to have 4 equal parts, so the width of each part becomes 1. Now let us go to this general setup today. From here to here, if I ask you what is the length, you say the length is 4. But how many rectangles are involved in this problem? How many?
1.
Why do you say 1? So probably
K times 10 is 4 divided by K.
not k. How many rectangles we have? I don't know. It was. I was thinking it's very, very simple. Might be I am wrong.
Rectangles.
What?
A rectangle.
No, the number of rectangles. How much is the number of rectangles? How many rectangles are involved? Might be we should skip this one. I thought that it should be easy because.
Is it infinitely many?
No, not yet. I don't know why this is so hard. So how many rectangles I had here? Can you see how many rectangles I had here? 4. The last number is x4. How many rectangles I had here? 3. The last number is x3. How many rectangles I had here? 2. The last number is x2. Yes? So you totally missed the logic, or you totally forgot what you learned actually quite well, or that was my impression that you learned well. How many rectangles I am considering here?
4.
What? Yeah, please repeat once more.
N.
Yes, exactly. N. N is the total number of rectangles. I am adding n rectangles area together, and then I want to increase n to infinity. It means that then I will consider infinitely many rectangles. N is the number of rectangles that I am considering. I don't know why you say k, 2 random numbers you are throwing out. Okay, I don't know. Which part you don't understand? Might be you have forgotten the video. So it is very important, by the way, I told you that whenever you see something for the first time, according to the research, you have to review it at most in 24 hours. Otherwise, 80% of that is gone. So you need to find a way, when you learn a new subject, go back to it. The best optimized way is that you go to it once more before 12 hours, at least to have a review. Otherwise, what is in your short-term memory, which is compared to RAM of a computer, will not be able to be transferred to your hard disk, which is your brain. Okay, so then you will lose it. And then it means that more or less you will fail to continue. Okay, so let us understand this is what is going on. Might be, I don't know. I was counting on your memory. So here, what I told you, I showed you that we consider one rectangle, two rectangles, three rectangles, and every time that I am increasing the number of rectangles, I am making a better and better approximation. Then we realize that if I can do it infinitely many times, if I can consider infinitely many rectangles, then I can hope what I get is the real area. Okay? So, how can we do infinitely many times? We say that let us consider n rectangles instead of infinitely many, because infinity is not a number that I can work with. So I consider n rectangles, and I add the area of n rectangles. I will get this Riemann sum, but at the end I take the limit of this sum and send n to infinity. By the way, what I have put in the box is not a university lesson, it is in the book. The reason that I am bringing this up, because essentially it is in the book. Everything that I mentioned in the previous session, except this calculation, is in the book. And I thought that it might be better if we solve a non-trivial problem to understand these concepts. So I want to use the same trick to find the area of this region, the exact value of the area of this region. For this region, there is no other way so far, if you haven't studied integrals yet yourself. Here, at least we could find the area by a method of the area of a triangle. So you might say it's not very interesting. If I can solve it so easily, why should I bother to go through this? But here, at least at the level of your knowledge right now, there is only one way to calculate this area, and that is using this formula of the limit of the Riemann sum. Okay? So what is the procedure? By the way, these are some exercises. They consider it E-level problems, okay? They ask you to calculate the areas using 3 rectangles, using 4 rectangles. So these are questions in the book. And then some of them are considered E-level questions, okay? The only thing that I am doing it here, and this formula is also in the book. The only thing that I am doing here for you, I am trying to show how tedious can be using this formula to calculate the area. I want you to feel it exactly. What are the problems? If I really want to calculate everything here, I want you to have a better appreciation towards Newton, yes? Who invented that, okay, come on, instead of calculating this, you can do this. Okay? Is the logic again clear or not? Please let me know. Are you happy with my explanation? Everything you think is correct or not?
Yeah.
Okay. Now, the only thing that I have done here for you, I couldn't draw n rectangles. Can you draw, can you give me n apples? Please give me n apples. Can you do that?
It will take a long time.
No, n apples. Can you give me n apples? No, because the first question is that how much is n? Okay? I'm asking you n apples. Okay, so this is why I cannot draw n rectangles. How can I draw n rectangles? Because I don't know the value of n. Yes? So in these kinds of problems, I pretend that there are other rectangles involved. I don't want to distract myself with all those rectangles that I don't need. Of course, I need all of them, but let me concentrate on one of them. Say the kth one. I have n rectangles. If you say how much is n, I don't know. N is a number. For example, 10. And let me concentrate on one of the rectangles from the number 1 to number 10. Let us call it the kth rectangle. Is that understandable now? Okay. Now let me ask you once more again. Okay, what is delta x in terms of n?
Four divided by n.
Thank you. Who said that?
Kevin.
Good. Thank you very much. Everyone understands that? Because my length is 4 units. If I divide it by 2, each unit becomes 2 units. If each subinterval. If I divide it by 4, it becomes 1. If I divide it by 10, it becomes 0.5, 0.4. If I divide it by n, it becomes n divided by 4 divided by n. I myself get confused now. Okay. I don't know. Is that understandable or not? So you see, the reason that I want this, because my goal is to calculate this. So what are the ingredients? One of them is delta x. Okay, I am relieved now because I have my delta x. I have my delta x here. Okay, now what was mk? Can you tell me? If I want to show mk here, where is mk? Can you tell me? Where?
In which interval?
No, you shouldn't ask this. M sub k means the middle point of the kth interval. So I don't know what is going on today. Let us skip this. I think it's hard for you. I don't believe it is hard at all. There is something going wrong. Or I cannot see your faces. Might be I am misunderstanding. But M sub k is the middle M1. Do you understand, by the way? Might be you don't understand this. Do you understand what is the meaning of M1? Do you understand what is the meaning of this one? Please, someone tells me.
The middle point of the first rectangle.
Exactly. So what is M2?
The middle point of the second one.
Okay, so what is MK?
The middle point of the kth one.
Yes. So I don't know why, Dylan, you asked the middle point of which rectangle?
Sorry.
No, I just want to make sure that you understand what's going on, okay? So it means that, do you agree that MK is here? Do you agree with me or not? Okay, please don't. Yeah. So MK is there. Okay, no worries. But MK is there. Okay. Now, do you agree, if I write this, do you agree with me or not? MK is equal to xk minus 1 plus xk divided by 2. Do you agree or not? Yes, because this is the middle point between these 2 points. So if I want you, what is the value of this middle point? It is the average between these 2, and I took the average. Everybody okay with that? It took longer. So now I write x1 over 2, and now let me write x sub k minus 1 here. So what is x sub k minus 1? It is k minus 1 delta x plus, what is xk? Xk is k delta x, and then I factor a delta x out, so it becomes k minus 1 plus k delta x, and then it becomes 1 over 2 2k minus 1 delta x. if you don't understand, please interrupt me. K minus 1k, I add them together, it becomes 2k minus 1. I just factor a delta x out, yes? And if I ask you what is delta x, you already know delta x, so let us substitute them. So it becomes 1 over 2, 2k minus 1 times 4 over n, but this 2 and that 4 can be simplified. I get a 2 there. So now let me write it in finalized form. Finally, m sub k is equal to 2k minus 1 times 2 over n. Okay, but let me write 2 over n on the left hand side. Yes? Agree with me or not? You see, 2k minus 1, I am left with 2 over n. What I did, I wrote it on the left. It doesn't matter. So everyone confirm that. Are you happy with this formula in the box? If you are not happy, please complain. Okay, now tell me what to do next. You have to solve this problem because I think it's simple. You are confused. Yeah, this is something, I don't know if you are scared about the problems or you think the problem is so hard that I cannot understand. All these psychological effects will prevent you from seeing the simplicity of this problem. It's not hard at all. It is tedious, not hard. There is a difference between these two. Hard problems in mathematics is a problem that you don't know where to start in the first place. But here, we have a lot of things we know what to do. I'm just following this thing step by step. This is what you can learn. Okay? Now, let me tell you, I'm asking you, I want to calculate this one. What more do I need to calculate? Anyone, I want to hear from you. We can consider this as an open session. Yes, discussion session or whatever you want to call it. So what is the next step?
We want to calculate delta x.
Delta x is already calculated. It's in the box. So this one, so let me put a mark here. Delta x is calculated. F of mk is calculated. What should I calculate now? Trust yourself. You see it, but I don't know why don't you say it.
Calculate the sigma.
No, no, something is left before going to sigma.
The function.
Yes, exactly. Because mk is calculated. But I want to calculate f of mk. Yes? So, now tell me, what is f of mk? What is f of mk? Say something.
mk squared.
Yes, everybody agrees because my function f of x is x squared. So f of mk is m sub k squared. Yes? And now I don't have any problems here because I already calculated mk. So good, I can replace that. I can replace mk with that expression. Then it becomes simple algebra. 2 over n to power 2 becomes 4 over n squared. Yes? And the other one becomes 2k minus 1 squared. But you learned in Math 1C, you see, you are using your skills to solve a problem. There are many problems involved. This is the nature of mathematics. I didn't know that I have to use squaring rule, but it is happening. If you have already done your lesson, it is easy to do that. It becomes the first one to the 2, 2 times the first one times the second one, and then the second one to the 2. Yes? And let me multiply that 4 in. Yeah, we can keep it like this. So this is f of mk. So let me write f of mk is equal to 4 over n squared, 4k squared minus 4k plus 1. Yes? Okay, now can you tell me, so let me put another check mark here. F is also calculated. So what should I do next? What should I do next? Thank you. I want to calculate the sigma. The next step, you see, I am doing it one by one. You need to be patient if you want to do mathematics, okay? So the sigma, let me make it smaller here for you. So the sigma, k goes from 1 to n of f of mk delta x becomes equal. Your duty is to substitute things. You already calculated f of mk, so you write it 4 over n 4k squared minus 4k plus 1, and then you see that you have a delta x. Delta x is 4 over n, so you put another 4 over n here. Oh, sorry, I made a mistake. Here is 4n squared. Yes, this is f of mk multiplied by 4 over n. And nobody leaves it like that, because 4 multiplied by 4 has a better name, n multiplied by n squared has a better name, so why not? And then the limits are k from 1 to n. Then let me repeat this again, and it becomes 16 over n cubed, and then I will have 4k squared minus 4k plus 1. Yes? So we got it. This is something we need to calculate, and this is the hard part. I was thinking that we come to it very quickly, but anyway, I hope that you learned quite a lot in these calculations. So this is the hard, troublesome problem. You remember, if I go to the previous problem, this sum was not that hard. This sum was of this form. You compare this one. In the previous problem I got this. In this new problem I get a more complicated sigma. In this problem, if you remember, this sigma was an arithmetic progression, and I knew how to deal with that. Here, this is a harder series. We know how to deal with that, but you don't know. I will tell you what to do, but at least I want you to see it becomes harder. You see, when x goes to x squared, the sigma that I have to calculate becomes much harder. So let me, if you don't mind, let me take this one with me to the next page and try to, I don't dare to say enjoy, but let us enjoy calculating this, okay? Okay, so how should I calculate this? Suggestions. Oh, let me ask you in this way. I want to open the sigma up because your knowledge about sigma symbol is quite limited. Let us not deal with those parts. I want to open the sigma up. This is a Mat 1C problem. Can you help me to open the sigma up? What should I do?
And you start replacing the n value with the 1.
No, not the n value. What is the counter of the sigma? Don't get confused. The counter is not n, the counter is k.
So it is 16 divided by 1.
No, no. You don't listen. K goes from 1 to n. So k, the starting value k is 1. You need to replace k with 1, and then replace k with 2, and then replace k with 3. Continue until you reach k equals to n. Is that understandable or not?
Oh, I'm sorry, yeah.
Yeah. Yeah, so these are very important things, because if you don't consider these things, when the calculation itself is tedious, I recommend you try not to make even one single mistake, because it will prevent you from seeing, because you don't know. This is the first time you are doing the calculation, you get the wrong answer. you have miscalculated, but you might interpret this miscalculation as misunderstanding. It means that your understanding was perfect, but your calculations were weak, and then you made a mistake, but your interpretation would be that I don't understand the problem, even though you really understand the problem. Okay, so what I do, I would write 4, I replace k with 1, and I don't calculate it. Let us be patient. The next one, I replace k with 2. Yes. The next one, I replace k with 3. And then I will continue until I reach to nth value. I replace k with the final number, which is supposed to be n. Okay? And now you see you have enough knowledge, but I want you to be able to use your knowledge in real problems. This is something that you need to learn in the future if you want to do some project work. Okay? So now this one and this one and this one and this one appears all the way around. Yes? So what is the best thing to do that? You know factorization, so let us factor it out. So what is left for me is this expression plus this expression plus this expression plus this expression. Yes? Yeah, let me be patient. We actually spent quite time, so let us at least get some results from it. So what I do, I will write the first one plus the second one plus the third one plus the last one. Yes? You see, I don't want to calculate everything myself. I want you to contribute this calculation. Okay, so let us do something like this. I underline this. You tell me what to do. What to do? No clues? Trust yourself. You know what to do. I'm sure. I am not saying to see the whole picture. What is the first step that you think might be useful for these terms? Please say something. Don't you see that we can factor 4 out? How many of you could see this but didn't say? Okay, so I don't know. So I factor 4 out. It becomes 1 squared plus 2 squared plus 3 squared and then plus n squared. Yes? At least confirm that you understand this. Okay, let me underline another one. I underline these. Tell me what to do. Now you have experience. What to do, please? Hello, are you with me or not?
Could it be that you first put a negative sign and then factor 4 out?
Yes, yes. Who was it?
Martin PG?
Yeah, thank you. So I take minus 4 out. Why don't you say that? I don't know. Because, let me tell you something. This is, by the way, you learn in practical problems. You see, you have learned about factorizations and things like that. when I was teaching you factorization, of course I am giving you examples related to factorization. This itself is a very big hint, because you know that that topic is related to factorization. So your brain only goes to find a way to factorize. But if you understand this factorization deeper, then you can use it in practice. Do you understand now what I was telling you? This is a good problem, by the way. Let us take it as just an experiment today. Okay? So every one of you knows what is factorization, but when it comes to a little bit tedious problem, first of all, you get confused, and I believe that most of you are thinking this problem is impossible to understand, which is totally wrong. This is the problem I solved. Of course, in that case, I was in front of the students. I did it with Math 3C students last year, and more or less, the people who I knew that they have a good background of mathematics, they could understand it quite well because they were answering my questions. Might be this is because of this distance learning that we cannot have eye contacts, especially I don't see you. I'm just like a crazy person sitting in front of the computer talking to himself, you know, because I don't see your pictures now. Okay, but this is very important to understand. This is the real meaning of understanding and being able to do mathematics, to learn it and be able to use your knowledge. Okay? Okay, now let me make me happy at least. Tell me this one. What can I do for this? What can I do?
Is it just +4?
No, don't you see these dots? Don't you see these dots? You are close. Yes, 1 plus 1 plus 1, 4 times is 4. But this is not 4 times. How many times you see 1? 1 plus 1 plus 1, dot, 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 plus 1. How many ones you see? N. Thank you. Why? Because the sigma goes from 1 to n. So I have n terms. Each term involves a 1 at the end. N terms involves n ones at the end. I am adding n1 together. So what is the answer? Tell me, everyone. It is n. Yes, it is n. I am adding 1 to itself n times. So it is n. Thank you. Okay, but do you see that what is happening now? If I ask you about this in principle, if you have done your homework right, you know this is an arithmetic sum, and it's a famous one. This one is a big problem in itself. I really want to avoid it right now. There is a formula for this one, but not this formula, because this series is not an arithmetic series. The first one is 1, the second one is 4, the next one is 9. You see that these are not arithmetic progressions. But the hard part is to calculate this one, and I just write you the formula and I ask you to trust me on that. The formula is n times n plus 1 times 2n plus 1 divided by 6. Now let us do some simplifications. This 4 by 2 becomes 2 times. This 6 by 2 becomes 3 times. So it becomes 2/3 of n times n plus 1 times 2n plus 1. Now this 2 and that 4 are cancelled. This is 2 times. So the answer would be 2 minus 2 times n plus 1, and then I have an n at the end. Okay, I just want to wait for you. What is the next step? You see, simplification is an art in mathematics. You should be very good at it. Okay, and by the way, just coding and using computers, it doesn't help. It helps if you already know how to solve the problem. If you want to solve a new problem, calculating using computer doesn't help you that much to understand what is going on. Okay? Now tell me, if you want to simplify this problem, what is the first thing that you do?
You simplify.
Pardon?
You simplify.
Okay, how? What is the first step you want to choose for simplification?
In the parentheses, you multiply.
Yes, this is one way, but I prefer, this is why I am telling you, respect what you have learned so far. I have tried so hard to teach you these things because I told you my goal is to make you independent of the teacher. Yes, it is better to factor an n out because n is common, and when I take it out, that n at least cancel one of these n's and makes the calculations easier. So let me just do it fast. So n goes down. So there is no n here, I pull it out, and this n that I bring here will cancel one of these, it becomes 16 over n squared, and then what is left for me is just this one. Yes, and then what I do, this I don't expect you to know what to do, but let me simplify this as much as possible. So this becomes 16 over n squared. So here I multiply these two, as Dylan said, so it becomes 2n squared plus n plus 2n plus 1 minus 2n minus 2 plus 1. I am multiplying these two. I multiplied minus 2. I am trying to simplify as you said, okay? So the next step is 16 over n squared. I multiply, this becomes what? Let me write everything here. This becomes 3n, okay? And then this is minus 2 and plus 1 becomes minus 1. And I have a 2/3, I have to multiply. So it becomes 4 over 3n squared. This one multiplied by 3n, 3 and 3 cancel, 2 times n, it becomes 2n. And then the next one, 2/3 times 1 is 2/3. And then I have minus 2n minus 1. Another simplification, 16 over n squared, 4 over 3n squared, this 2n, that 2n are gone, and then what I get is minus 1/3. Okay? And now let me multiply it. That is the last step. 4 over 3 times n squared minus 16 over n squared times 1 over 3. If I ask you what is the simplification, you see that this n squared here and that n squared are gone. 16 times that is what? Is 64 over 3 minus 16 over 3n squared. Congratulations. So f of mk delta x becomes equal to this. Yes? Everybody agrees? A big yes or a big no? Yes. Okay, but there is one more thing left. Let us go back. So now check mark on this one as well. What is left? Everyone tell me. What is left? Limit. Thank you. Now you see you are feeling confidence now. It was clear, yes? I want to take the limit. Even though you haven't studied limit formally, but I am completely sure you can understand what's going on intuitively. I want to test your understanding. Please let me know. If I take the limit and sends n to infinity, it means that I am taking limit from this expression. Okay? Why is that? Because I calculated this part, it is this guy, and I am supposed to calculate the limit of this, so it means that I have to calculate of its equal. Now, can you tell me what is this limit? I know that you haven't studied limits formally. in your curriculum, but you have an understanding, intuitive understanding of limits. Can you tell me what would be the limit here? Can you tell me what is the answer to the limit based on your intuition, intuitive understanding of limit? I want to give me an answer for the limit. It's not hard. If you understand what... Yeah?
And we set to infinity.
Yes?
And divide by infinity and divide by infinity should be 0.
Yes? So who is speaking?
Jacob.
Yeah, thank you, Jacob. So what would be the answer to the limit at the end?
0.
No, this part is 0.
64.
Thank you very much. 64 over 3. Yes? So Jacob is actually saying that I am sending n to infinity. It means that n is infinitely large, bigger than 1 billion, 1 trillion, whatever you might imagine. And I am dividing 16 divided by infinity to power 2, again more stronger. So nothing will left from this poor guy. Yes, so what is left is 64 over 3. So the answer is 64 over 3. Isn't it amazing? So we were able, you see, this was a project. It was a project and you learned a lot if you really want to do the projects. Many people, when they want to start learning something, they accept a project to work on. To be able to solve that problem, they learn a lot in the middle, in the way to learn to finalize the problem. Okay, so the final answer we got was 64 over 3, and this is amazing. We didn't know about this before because this is just something you start learning this year. This is a curved region. At least one boundary is a curved one. It was not simple as that, but it was doable even though tedious. But let us now, how many of you remembered Newton's method? Can you use the Newton's method for solving this problem? Do you remember what I said? Is there anyone can repeat Newton's method? I want to use the Newton's method for this problem. Is there any one of you can say what is Newton's method? I will study Newton's method. I will teach you Newton's method formally, but I told you what is the content. Anyone, please?
Yeah, I don't remember exactly, but it has to do with primitive functions, and you subtract.
Exactly. So you take the primitive function of your functions, and you put the numbers, the initial number and the final number, into the primitive function and subtract them. Okay, exactly. Thank you very much. So here, what is my function? It's x squared. What is the limit? Is from 0 to 4. Yes? Everyone should know this. This is an E-level problem. What is a primitive function? So let me change my color. So what is a primitive function for f of x equals to x squared? What is a primitive function, everyone? Everyone?
x3 divided by 3.
x3 divided by 3. So now I substitute 4 there. I substitute 0 there. And subtract them. 4 to the 3 means 4 times 4 times 4 is 64 over 3. This is 0. If you subtract them, what is happening? Yes, so this is the Newton's solution, 64 over 3. This was Archimedes' actually solution, 64 over 3. Now, which one do you prefer? Do you prefer I give you an exam question like this or like that? Okay, So it is extremely important, so you realize that we were able to use this formula. But you hopefully agree with me that even if it is possible, it's extremely tedious. You see, our function was a very simple function. It was just x squared. And then the sigma. You see, now if someone asks you what is the hard part in this part, you would say calculating this sigma is hard. Even though we spend more time in these very simple stuff, I didn't believe that you will stuck on it. Might be you have forgotten. The main obstacle here is calculating this sigma. And if this function just becomes a square root of x, then this sigma will involve a square root of k. End of the problem. We don't know how to calculate the sigma for a square root of k. So, even though in principle this formula is correct, but for practical purposes, it's not very nice and sometimes impossible to calculate. Because this sum becomes very involved. This is the point. But if I want to use Newton's formula, you immediately can calculate. If you have done your homework fine till now, you immediately know how to calculate the primitive function for x. And when you got the primitive function, you put those numbers there and subtract them, as simple as that. Who cares about sigmas in Newton's method? So it is an extremely powerful way of thinking about the same problem from a very, very different perspective. Something like primitive functions, which was just a game for us till now. But at least you see a practical application of this. Okay? There is not much time left for us. I want to make sure that if you understood, I don't want you to understand the calculations. That's up to you if you enjoy these kinds of calculations. But I want you to understand this formula, which is in the book, is not completely useless. It can be used to solve some of the simple problems, but we will get stuck if the function becomes a little bit more complicated than x squared. It's just a square root of x. We don't know how to solve this problem using this method because the series involved is not doable like this. Here I had a formula for this, but if I ask you, do you have a formula for this? No, we don't have a formula for this. That is the problem, that we cannot solve this using this method, but we can solve this using Newton's method. Now I want to teach you something on GeoGebra. That's also good to know. I have given up using Classics 6. I don't know. I feel that it is much easier to work this Classics 5. The only downside is that you need to type like a computer, not like handwritten typing. So there are two functions that I want you to learn. Okay, for example, you start typing rectangle. You see some syntax pops up and then rectangle sum. You click on it, then it asks you to give you the function. So I say x to the power of 2, and then I use the right arrow key, jump here, start x value. In our problem it was 0. Yes, and then I use the right arrow key, I jump there, it was 4. Do you remember? I considered from 0 to 4. This is asking you, give me how many rectangles you want to make involved. If you know how many rectangles, if you want to solve some of the book's problem, they mention use 4 rectangles, use 5 rectangles. You then put that number here. But if you want to explore, I recommend you to put n rectangles. And this I want to remember, this position for rectangles, put 0.5. So n 0.5. Remember this, because there are 3 types of Riemann sums. Lower Riemann sum, upper Riemann sum, you don't study them. You only study the middle point one. The middle point one, so remember, you should always put 0.5 there. There are 0, 1, and 0.5. You only study in your book 0.5. Okay? And then as soon as you press enter, it asks you what is n. You see, poor computer is confused. You see, I told you give me n apples. Now I am giving the computer, give me n rectangles. Computer doesn't know what to do. He's asking, am I allowed to make a slider for n so that I can vary the values of n? I said, yes, poor computer, do that. And now you see, you get this one. Okay, so let me make it. So this is crazy. I don't know why this guy doesn't understand that. So okay, so this is the slider you can change. You see, you can change this slider to create. But of course, in our case, this is meaningless to have minus 2.7 rectangles. So what I do, I right click on it and go object properties. And then you see that if I get rid of my own face here. Okay, so now you see the interval is from, this is the not the interval, this is the interval for your slider. Let us start with one rectangle. Yeah, let us start with 0 rectangles, and let me go to the next one and, for example, put 100, for example. Okay, and the increment is also good to know. And let me make increment. How many? So I want to go one by one because 1.5 rectangles doesn't make sense. Okay, so I will go one by one. The first value is 0. I want to have the second value for n equal to 1, so I choose the increment equal to 1. And when I am done, I can close that one and come back here, and then I can increase this one. You see, this is the number of rectangles. The bad problem is that you don't see the curve. Okay, no worries. You go back here and draw your curve. Y equals to x to the power of 2. Yes, and then press enter. And then you see this is gone. You just bring it back again. Oh no, sorry. You just start playing this. And you can change the numbers. You see, and this number that you see here is the sum of the areas of these rectangles. So I really recommend you try to solve some of the book's problems using GeoGebra. It's extremely powerful. You need to learn that. So you see, let us do it once more. You see, I go up to 100. So you see this, they are very close to the real area. So you can just do some game for yourself. It could be very fun. And then another thing that I want to teach you is another notion. We will come back to it. It's called, we can talk about that later. So I hope that you work with GeoGebra here. This is extremely important. Try to solve some of the book's problem using GeoGebra for me. Okay, I will write on a Schoolsoft which problems on which pages you have to solve. Some of them, of course, it's good to do it with hand, but check your answer. Instead of going to the faucet to see that you have done it right, check it with GeoGebra. It provides you the opportunity to learn GeoGebra as well, which would be an extremely important tool and powerful tool for your future. So let me repeat. So you just go and write rec. If it is in English, you might have downloaded the Swedish version of that. So then you need to find the word in your own language. But anyway, this is the command that you want to use. Everything is clear except the last one. Remember, for the last one, you need to put 0.5. Okay. Thank you for being with me here, and I apologize if I confused you. But this is my real belief that you learn mathematics if you want to solve hard problems. Then you will start appreciating. You see, factorizations, squaring rules, sigma rules, taking limits, everything more or less was involved, and you knew all of it in principle. But you need to know it in a way that you can use it. Please concentrate on this phrase. If you don't use your knowledge, why we are gaining knowledge in the first place? It's extremely important to think about it. Okay, so again, I apologize if it was if you are confused. Don't worry, just forget about this session. I will write down what you need next session without any distractions. We just immediately. Let me again tell you that the problems in the book are much simpler, but not too simple. Okay? Okay, so let me end the video.